In this video, I am going to explain the geometrical representation of the BPSK signal. We know that the BPSK signal carries the information about the two symbols. Those are the symbol 1 and symbol 0. We can represent the BPSK signal geometrically to those two symbols. We know that the BPSK signal is S of t equal to B of t, the square root of 2p cos 2 pi f naught t. Here the B of t value is either maybe the plus or minus 1. Here the p indicates the power. This is the carrier term here. That is equation number 1. After rearranging the equation 1, the equation becomes S of t equal to B of t, the square root of p into tb into the square root of 2 divided by tb cos 2 pi f naught t. Here in this equation, if I cancel this square root of tb and the square root of tb, again the equation 2 is same as the equation 1. Let us, if I take the orthonormal carrier signal, that is the phi 1 of t equal to the square root of 2 divided by tb cos 2 pi f naught t. In this equation 2, this term that can be written as the phi 1 of t. Then we can write the equation is S of t equal to B of t, the square root of p into tb phi 1 of t. That is equation number 3. The energy bit EB is defined as in terms of the power P and the bit duration is TB. The TB indicates that there is the bit duration of each symbol. The EB equal to P into TB. The S of t equal to plus or minus this value, that is the value of, that is the B of t in the equation 3, and square root of P into TB, that directly I can write it as, that is the EB, that becomes square root of EB into the phi 1 of t is, I have written here phi 1 of t. Here on the single line of phi 1 of t, this is the single line of phi 1 of t, there will be the 2 points. This is the one point and this is the another point. One point is located at plus square root of EB and another point will be located at minus square root of EB. The first point is represented as symbol 1. This is the represented symbol 0. The distance between the two symbol is, that is the d equal to the 2 into square root of EB. The distance I have calculated like this here, d equal to plus EB, that is the representation of the symbol 1 here. This is the representation of the symbol 0. If I add both the energy of the bits, you will get the distance is equal to 2 into square root of EB. The bandwidth of the BPSK signal is the minimum bandwidth, that should be equal to the maximum, the frequency of the band limited signal.